Microservices versus Monolith. Which architecture is right for your .NET app? Microservices versus Monolith. Which architecture is right for your .NET app? That's what we're tackling today. If you've been wondering about .NET Microservices Consulting, stick around. Now, what is a monolithic .NET application? A monolithic .NET application packages UI, business logic, and data access into a single deployable unit. In ASP.NET Development Services terms, this means one solution, one build pipeline, one deployment artifact. The entire application goes out as a unit whether you changed one line or 500. Monoliths are the default for a good reason. They are simpler to develop, debug, and test locally without spinning up Docker clusters or managing service registries. For the right team at the right stage, a monolith is not a compromise, it's the correct choice. For most teams, a monolith is the right starting point. A single codebase gives you shared libraries, atomic database transactions, and no network calls between your own components to debug. Early-stage products change shape constantly, and refactoring a monolith is far cheaper than rewiring service contracts between a dozen independent services. Next up, what are .NET microservices and when do they make sense? Microservices split an application into independently deployable services, each owning its data and communicating via APIs or message queues. In the .NET world, this typically means multiple ASP.NET applications containerized with Docker, orchestrated by Kubernetes, and communicating over HTTP, gRPC, or a message broker like Azure Service Bus. The appeal is independence. Teams can deploy without waiting for anyone else, and a failure in one service doesn't cascade across the system, assuming you design for it correctly. Each microservice owns a bounded context. Order management is one service. Inventory is another. Customer identity is its own. ASP.NET and API development services define the contracts between these services, and those contracts become the team boundary. Next up, now, microservices versus monolith, a direct comparison. The takeaway: microservices solve organizational scaling problems. They don't inherently solve performance problems, and they introduce distributed systems failure modes that a monolith simply doesn't have. A monolith makes in-process function calls measured in microseconds. Microservices make network calls. Even on a fast internal network, adding 5 to 10 milliseconds per hop across 6 services in a single request chain is meaningful. This doesn't make microservices slower overall, but the latency profile changes and has to be explicitly designed for, through caching, async messaging, and circuit breakers. Every additional service means a separate deployment pipeline, a separate log stream, and a separate health check. Teams new to enterprise application development consistently underestimate this cost. The tooling to make microservices manageable, including service mesh, distributed tracing with OpenTelemetry, and centralized log aggregation, often represents 3 to 6 months of platform engineering before you write a single line of business logic. Let's talk about how to modernize a legacy .NET application. Most legacy app modernization projects begin with a working but painful system on .NET Framework 4.x that needs to move forward without pausing feature delivery. That constraint shapes every decision. You can't tell stakeholders the app is down for 18 months while you rewrite it. The question of rewriting versus refactoring is covered in depth in our guide on when to rewrite, refactor, or replace a legacy application. The short answer: full rewrites fail more often than refactors, and they always take longer than anyone estimates up front. The strangler fig pattern is the standard approach for incremental .NET application modernization. You place a routing layer in front of the existing application, route new features into new services, and gradually migrate existing functionality one bounded context at a time. Now, moving on to blazor and API-first patterns in a microservices architecture. One question that surfaces in almost every .NET 9 migration engagement is what to do with the front end. ASP.NET MVC views and legacy webforms UIs don't translate cleanly into a microservices model. This is where blazor development services become a practical part of the conversation. Blazor server renders UI on the server using SignalR. Blazor WebAssembly runs C# directly in the browser via WebAssembly. That distinction matters more than it sounds. Blazor server keeps all business logic on the server. This suits applications in healthcare, financial services, and logistics where sensitive logic should not execute in a browser environment. Each user interaction makes a server round trip, which adds latency but keeps the processing model simple and secure. For internal tools, admin dashboards, and line of business apps, this trade-off is almost always worth it. Let's talk about what to expect from .NET Microservices Consulting. .NET Microservices Consulting typically begins with an architecture review of the existing system, not a proposal for a greenfield build. The goal is to understand current coupling patterns, identify natural bounded contexts, assess DevOps maturity, and produce a phased migration roadmap with realistic timelines and risk ratings per phase. Microservices specializes in .NET modernization with human-in-the-loop governance for enterprise applications, meaning every architecture recommendation is reviewed by a senior engineer before it becomes a project commitment. That layer of human judgment matters when you're making decisions that will affect systems running production workloads your business depends on. A serious .NET development company will not recommend microservices to a team that isn't operationally ready for them. The review has to cover team structure, existing deployment automation, monitoring coverage, and whether proposed services would genuinely own their data or just proxy to a shared database. Microservices sharing a single database are a monolith with more network hops, the worst of both worlds. Let's talk about now. Conclusion. The microservices versus monolith question doesn't have a universal answer, but it has a useful reframe. Is your team's velocity limited by the architecture, or by something else? If deployments are slow because of coupling, if incidents in one module take down unrelated features, or if two teams cannot ship independently, .NET Microservices Consulting is worth a serious look. If your team is small and the product is still finding its shape, the monolith is almost certainly the right home. .NET application modernization doesn't require choosing between extremes. The Strangler fig pattern lets you move incrementally. .NET 9 migration gives you a modern runtime foundation, service by service. The goal is an architecture that fits your team and your business today, with room to scale as both grow. If you're at the decision point now, Microservices brings ASP.NET Development Services depth, microservices architecture expertise, and human-in-the-loop governance designed for enterprise organizations that cannot afford to get this wrong. Contact us for an architecture assessment that tells you honestly which path makes sense for your specific situation.